So welcome to Mod 2.2, completing the square. I'm going to let you guys do 1 and 2 because I'm confident that you can use the area model to multiply out number 1 and to factor number 2. I'm going to start with number 3 that says, what do you need to add to the following expression to complete the square? And so our first example says we have x squared plus 6x. I would like to remind you that this big square here is the x squared, that we've multiplied x times x together. And these little bars, this is an x, this is an x, that one's an x. And we have 3 over there. So we have an even number of x's on both sides. So we have a 3 down here because we're multiplying 3 times x to get those. And we have a 3 over here. So when we multiply our 3 times 3, we get 9 individual little units here. So we are adding 9 to complete our square. Same idea over here with the x squared plus 8. Again, this is our x squared, and I have 4 little x's right here, and I have 4 little x's over here. So this is going to be x times x, and again, this is a 4 right here and a 4 right here. So when I multiply those that are evenly divided in half, I get 16 little squares when I multiply those together. So that is what my addition to make it a completed square is. So I have x squared plus 8x plus 16 there. So we're going to have to do this on our own. Going back to our area models here, it says still, what do we need to add to the following expression to complete the square? I have x squared plus 6x. So when we reduce it to our area models that we were doing before, we have our x squared here, and we have our 6x that it needs to add to. We have divided it evenly in half in example 3, so we're going to do the same thing here. We're evenly dividing 6x in half, so when we divide 6 by 2, we get 3x and we get 3x. When you're factoring, you're taking out an x, you're taking out an x. Here, it needs to come out as the 3 and the 3, so that when I multiply them together, I can complete my square to get the 9. And same thing on part B. I have my x squared. Again, I need 2 numbers that evenly add together to give me the 8. When I split that in half, I get 4x and 4. When I'm multiplying my 4's together, that is where the 16 is coming from. And again, when you factor it, you see that you have an x plus 4 and an x plus 4, which would get you your perfect square, x plus 4 squared. Okay. Turn the page over to page 5. We still have a couple more of those. These ones have minuses in them. We do them the same way. I have x squared. What do I need to divide that negative 10 into? I need to divide it into 2 parts, so I get a negative 5x and a negative 5x. When I multiply those negative 5's together, I get 25. I need to add 25 to both of those. And when you factor, again, that's the whole idea behind this, is that when I factor, I get x minus 5 and x minus 5 to give me my perfect square of x minus 5 squared. Part B is a little harder with the x squared minus 5x. I'm still dividing that 5 in half. So I have a negative 5x. When I divide it in half, it does leave a fraction. I have negative 5x, negative 5 halves x. In both of those, I multiply those negative fractions together to get a positive 25 over 4. So again, that's a negative 5 over 2 times a negative 5 over 2. When we multiply our fractions together, we multiply straight across, 25 over 4. So I'm going to add my 25 over 4. Again, when I factor, it factors quite nicely into this negative 5 halves that we've done. Negative 5 halves here, a negative 5 halves here, we get x minus 5 halves squared. No need to be afraid of those fractions. All right, so we're going to do the whole process now with these back numbers here, our constant term. We have the c value that's not helping us factor completely, so I have to do the work. So for completing the square, I'm going to start by saying we have x squared and minus 4x. I'm going to move this 2 way over here to the side. This part now becomes the problems that we have done before. I need half of this little guy. So half of negative 4 is a negative 2. I'm squaring it, and I need to add and subtract it. So that I have not changed the value of the equation that I have. I've just inserted some extra stuff to help me. I have y equals x squared minus 4x I'm going to simplify this now to a plus 4 and a minus 4 plus 2. So you can see that I have added in a 0 in here, so I have not changed the value of the equation. I'm going to add parentheses here so that I can factor, which is what I was doing in the previous several problems. So when we factor that, we end up with an x minus 2 and an x minus 2. And I'm going to combine these terms back here to get a negative 2. Rewrite it so that you see our perfect square. We have x minus 2 squared and then minus 2 more. This is our final answer. We went from standard form to vertex form. The process for doing that is completing the square. I went from standard form to vertex form by completing the square. Same idea on part B here. We have y is equal to x squared minus 8x. Again, I divide this b term right here in front of the x in half, so that is going to give me a negative 4 squared that I need to add and subtract. And so we have y is equal to x squared minus 8x. I have a positive 16 and a negative 16. And then I'm going to factor again these first three terms. So we have x minus 4 squared and then minus 5. Again, I did some work in my head. I know that when I factor the x squared minus 8x plus 16, it's going to factor into two of these. So I have just written it in the terms of x minus 4 squared and then minus 5. Feel free to use as many steps as you need to. On part C here, same idea. I have a negative 7x. It's okay that it is an odd number. Do not be afraid. We have x squared minus 7x. We're going to divide that in 2. So I have negative 7 over 2, and I'm going to square that, and I'm going to subtract it again. So I've added and subtracted it. So we have y is equal to x squared minus 7x. We're going to end up with a plus 49 over 4 and a minus 49 over 4. I'm going to factor these first three terms. You guessed it, it's going to factor into this b divided by 2 term. So I have y is equal to x minus 7 halves squared and then minus my 49 over 4. There are some steps at the top about what we've been doing. We're sliding that constant term over, that c term. On these next ones, we are going to be factoring. That's what makes them different. I am taking that b term and dividing it by 2, and then I'm squaring it. We're adding and subtracting. I'm then going to factor, and then I'm going to combine like terms. Again, in case you are wondering about where that b term is coming from,